Hello everyone, and welcome to, hopefully, the third and final part of Arduino coding lecture night. So, hopefully this is going to wrap up everything we've been talking about so far. We have, thus far, first part we talked about how to set up a sketch, void loop, void setup. We talked a ton about variables, integers. Last video part 2, we talked about digital write, digital read. We got into a little bit of if then else statements, not much. And we talked about analog write a little bit. And then we finally, here we are, we are going to get into if statements, delay, and if we have time, we're going to try and break down the difference between inputs and outputs. But we'll see what we get to. We might not get to that. Might be in the coding application video that we get to that. So, alright, good luck. Pay attention, keep good notes, because notes will be your best friend when it comes to pretty much anything. So make sure you have a piece of paper, pencil, or a pen, or whatnot. Your handout, crucial that you have. And good luck. I hope to see you on the other side, assuming you survive. Alright, so, last time we covered quite a lot of stuff. We broke down what this code is going to do. Just in case you missed that, though, this is going to alter the speed of a blinking LED, which means it's going to alter the speed at which the LED is blinking based on where a potentiometer or a variable resistor or a knob is turned. Okay, so that's what your handout is going to do. So let's move into what really the main event is today, and that is if then else statements. So if then else statements are used a lot in coding. You really can't get away with coding without using at least 3 or 4 if then else statements in your code. They are pretty crucial if you want a program to do some really cool stuff. Alright, so in the example that we actually did in part 1, where I explained digital read, I think it was digital read? Yes. So in that example, the if statement was used to make a button turn an LED on and off. So essentially, what we've done in the past where a button, so if this is our button, and then here is our LED, right? Here's the long lead. Essentially, before when we would just connect that in, and then this would be connected to 5 volts. And then when this button is pressed down, right? This is pressed down. LED turns on, happiness, yay! Okay, so we have not done that this time. We have actually done pretty much, it's actually the same result, but we've done it through code this time, which is really cool. It's good to think through these things. So, let's work through this if statement. So, if this condition is true, do this. That's probably pretty much the basis of what this is. So it's an if condition. So if the condition in between these two is true or false, it could be false, then do this. Okay, so if something is done, do this. That's pretty much what this boils down to. Okay, so let's go through something that kind of confuses people. See if you notice anything on this first line that doesn't make sense to you. Right now, looking at this, I can see one thing, maybe two, but let's just focus on the one. What's going on with this double equal sign? Why are there two? Okay, so I usually do this in class, and it helps, I think, everyone understand what's going on here. So I'm just going to do the same thing. If, and let's just say that our variable name is A, because I'm too lazy to write out button state, is equal to high. Okay, let's start removing things. And since I don't have an eraser, I'm just going to start crossing some stuff out. And you should notice that this starts to look like something we've already talked about. So let's go ahead and do that. So let's cross out this if. Okay. Now let's get rid of these parentheses. So no parentheses. Parentheses, you're evil. Okay, parentheses, he's gone. And finally, let's get rid of this double, or this one of these equal signs. ta-da! What are we left with? Well, let me write what we're left with over here, since my scribbles are too unreadable. That's what we're left with. A equals high. Guess what? That statement there will make A equal to high. Is that what we want to do? Not in the least. We do not want to make A equal to high. We want to check and see if it's equal to high. And if it is, do the next condition. So, that's, in my mind, why we do the double equal then sign. That just helps me remember, I don't want to set A equal to high. I want to check and see if. Is it equal to high? So hopefully that makes sense to some people. That's just what helps me remember it. Alright, so there's that. And another big thing, we have our own little curly cues. So when I say everything inside this if statement, this is what I mean. Everything between those two curly cues. In this case, everything in this if statement is this digital write LED pin high, which, take a guess as to what that's going to do. Pause the video. Okay, now play it. Guess what it's going to do? It's going to turn the LED on. Okay, high. Good. Alright, so that is the if part. But guess what? Computers are stupid. They do not know. They cannot really think for themselves very well at all. So they know what to do if the button is on. If button equals high. Now remember, button state is a digital read, so it's going to be a digital input, which means that it is true or false, because that's what Boolean is, true or false, or it's high, just put H, or low, just put L. That's what Boolean is, and that's what the button is. So you know it's going to be either high or low. So in this case, we've said if button state is equal to high, a digital write LED pin high, and then we need to tell it what happens if it's low, because it has no idea what to do. We haven't told it yet. So we say else if it's not high, if it is equal to low, digital write LED pin low. Alright, so hopefully the if statements make a bit more sense now. Alright. It really should be if then, else then. If that makes sense. So if this is true, then do this, right? Else, if it's not true, then do this, right? So that would make a bit more sense. But hey, I didn't write the rules. I just write them down on my slides. Okay, so that's the if then else statement. And finally, one of the last things that we want to talk about today is the delay command. We use that in the handouts, and it is actually extremely helpful. So delay is actually going to delay the sketch for as long as you set it. It's pretty self-explanatory. The only non-self-explanatory thing is this, and I'm so sorry that my slides are really looking weird today. When I design them, they look fine. Now they're all weird. I don't get that. But in milliseconds, 1 second is equal to 1,000 milliseconds. So if I wanted to pause the program for 4 seconds, I would do 4,000, because milli means 1,000. So that might be something to write down, because you're going to need that later on in math and science, because milli is very important. Milli is equal to 1,000. Okay, so just something good to know. A lot of you probably know that already, but it's very helpful to just keep that in mind, that the delay is in milliseconds, not seconds. So if you put 44 and it's extremely fast, it's not 44 seconds, it's 44 milliseconds. So don't start throwing your computer across the room when your program's not doing what you want it to do. Alright, finally, comments. This is something I don't get a chance to talk about a lot in class. Since we're doing extremely well here and we are moving right along, I have time to talk about this. Yay! Alright, so comments are written like so. // This is a comment. Comments have absolutely no impact on the code whatsoever. They do nothing. Absolutely nothing. They have nothing to do with the code. They do not change the code in any way. So don't go getting the idea that if you write a comment that says turn an LED on, it will turn an LED on. It will not do that. Okay, that's not what it does. Comments are just there. And let's get into actually why they're there. So comments are not completely useless, as I have been saying up to this point, or implying up to this point. Comments are actually extremely helpful to yourself and other coders who you go to for help. So if you need help with your code, like your code's not working right, and you're extremely frustrated, you just want to scribble out all your code. Sorry, that's the only analogy I can think of there. Okay, and you probably, the best thing to do would be to go to the Arduino forums, which are, you can actually go to Arduino, you might want to write this down. It's the same place where you downloaded the Arduino IDE, arduino.cc. So if you go to arduino.cc, there is a tab that says forum, and you can ask questions, or smarter thing to do would be to search for your question. Someone has probably already asked it and gotten lots of answers, so you don't even need to ask a question. You can just find one and then comment and say, hey, thank you very much, this was very helpful. Anyways, so when you post it on the forum and you think this line, let's say this line of code should do something, but it's not doing it, well, you probably typed it in wrong or something. You should put a comment that says, here's what I want it to do. This is what I want this code to do. And really, I should write this in a different color. Put a comment. And then a couple more lines, right? And this line isn't working either. Here's what I want it to do. And then you send it in and they say, so you want it to do this. Here's how you would go about doing that, all right? So hopefully that makes a bit more sense. So that's one reason. That's for somebody else. What about yourself? Well, let's say 1 month you start a project and you've got some great ideas and you don't write them down because you're like, I'm going to finish this really quickly, and then something happens. And yes, life happens and you don't get projects done as soon as you want them to. These recap sessions are a great example of that. I've been trying to do this for months and I haven't gotten it done yet. So I'm jumping at the chance now that I have an evening open. So let's say you forgot about what you're supposed to do. You come back to it in a few months and you have no idea what you were trying to do with that code. Well, comments would have been helpful. Had you been writing a few lines and commenting every so often what you want this line to do, and it doesn't have to be every line, but it has to be enough that you understand it, right? And you probably would have been able to fill in the blanks yourself, and you would have been able to, write up your code and complete the project you were working on. Okay, so comments are good for two people. This would be good to write down. Yourself, and the forums. Yourself and the forums. Probably this is going to be the biggest part, although this one, they're both important. But these are two of the biggest reasons I could think of for using comments. So write those down, you'll be good to go. Alright, so you made it through this 3-part lecture recap session. So this was like a lot. I mean, I think it's a good idea to break it up into these 3 parts, because when we did this in class and it was just an hour and a half, well, in Scranton and in Tannersville we have an hour and a half class. Honesdale students, you only get an hour, so. But in the hour and a half classes that we went through this whole thing, and I could see a lot of confused looks and I got a lot of questions. So I think breaking it up into smaller chunks really helped. And I think the next 2 application videos, and that's right, you heard me correctly, we're going to have 2 application videos after this. Not 1, because I don't have too many other lectures coming up until we get to the Raspberry Pi portion. So, for the next 2 weeks, you're only going to get, for the only recap sessions you're going to get are applications. So, yay! No more of listening to me jabber. Okay, so I think we're done now with the lecture part of coding. Next week we're actually going to break down two of the sketches we just worked through, and then we're going to start getting into circuit design, and we're going to move into a bit more coding using some of the example sketches in the Arduino IDE. Alright, good work. I hope you have like 3 or 4 pages of notes, because you're going to need it once we get started with these next application videos. Alright, we will see you then. Good luck.